Alright, geometry kids, here we go with 11-3. Before I get started, I just want to say, if you are new to this channel, like you're not one of my regular geometry students, you don't have an idea of the scope of most of these videos, or if you're someone I recently met at a conference, or you're a colleague from, you're another math colleague from SAS or another school even, I just want to tell you that this is not my standard level of content in these videos. I say that, and I want the geometry kids to hear that, because this section, area of a trapezoid, is really pretty easy. Actually, the last video also was, there wasn't a whole lot of content. I find myself sort of filling the time here to try to get a substantial amount of video. My point is, there's not a whole lot of content in this part of the geometry book. For more impressive videos, keep looking back into the chapters prior to this. Okay, so here we go. Chapter 11, Section 3, Area of a Trapezoid. This is going to go really quick. I might just do a whole bunch of examples to make you feel a little more confident about area of a trapezoid. After you come to class on the 13th, after we do a little do now that'll have to do with the content before that, this is the part that you're going to have to answer to, basically, when it comes to having watched this video and what you're responsible for knowing. These are the things you want to discuss in your group and not be embarrassed when you don't know. Have a look at that. Okay. So here we go, area of a trapezoid. Yeah, we just got through squares and rectangles and triangles and parallelograms and rhombi, so I guess trapezoid's the next thing to do. Yes, in the book they go through this great explanation of why the formula is what it is. First of all, let's just remember what a trapezoid is. Trapezoid is a quadrilateral that has two parallel sides. Our book is a little bit specific in that they require that the trapezoid only has two parallel sides. These sides have to not be parallel, which you may have heard bothers me a little bit, but that's fine. Some of the GSP stuff we do is going to allow these sides to be parallel. I guess it doesn't really break down this formula. It's just a little bit cranky, in my opinion. Okay, so yeah, I need to know the length of the parallel sides, and I need to know the length of sort of the distance between those parallel sides. How far apart are they in the perpendicular sense? And then once I know all that, here's the magic formula, that it's half of this height times this number plus this number. Now that looks kind of wacky. There's some parentheses in there. There's three numbers. We haven't had three numbers multiplied before. There's a half in there for some reason. But really, that's pretty much what section 11-3 is about. I promised on here in these notes, if you read them, that I would kind of prove that a little bit on here. Not that you're going to have to prove it, but what's really nice about seeing a couple proofs of this is that you come to believe it a little bit better. One of them is, this one's, I don't know, maybe the weirdest one, so I'll start with it. This thing would be a rectangle if, these are right angles down here and down here, but it's not a rectangle. I could think about the fact that this base has to be different length than this base if these sides are not to be parallel. You're going to have two parallel bases, and I constructed this so it's going to stay parallel. And I constructed midpoints on each one of those non-parallel sides, and I connected those. And I'm trying to get you to believe that this little side right here, this midline sort of the trapezoid, has to have a length that is the average length between these two. We did this kind of thing with triangles before. When we had midpoints, we connected this midpoint to this midpoint on a triangle. If you have a triangle and you connect midpoints, you're going to get, whoa, you're not going to get that. You're going to get, or that, you're going to get construct midpoints. You're going to get this thing that, no matter how I move the triangle around, is always going to be, this segment's always going to be half of this segment. I don't think that's hard to believe when we did that back in the triangle chapter. Same kind of thing here with trapezoids. I don't know if you believe me or not, or how much I need to wiggle this to make you believe that that middle segment, since sort of halfway between here, moving straight up to this one, it's going to be half of the, I guess, half the difference between this length and this length. One way to build on that then is, and hopefully Sketchpad will let me do this, pretend we made a rectangle that had this as one of its dimensions, and this height, this length between the this perpendicular thing between the bases as its height. So if we do that, we're going to have basically a rectangle that's exactly this big. It's going to go from there this big. It's going to go up here because it's going to be perpendicular, and it's going to be exactly that size. Now, would you believe that this rectangle has exactly the same area as this trapezoid? Think about taking this little triangle and moving it up into there, taking this little triangle and moving it up into here. You could sort of snap the area of the trapezoid into the area of that exact rectangle. Well, sure. And the height of that rectangle is the height of the trapezoid. It's still just h. And the length of the rectangle down here is the average of these two bases. And average, as you know, is take the first base, add the second base, and divide by 2. Or add them up and take half, which is kind of what that looks like. So the area of the rectangle is just that times that, which is the same as our area of a trapezoid formula. Base 1 plus base 2 divided by 2. That's the area of a trapezoid. Very nice. See, I'm already 6 minutes into it, and I've gone beyond what you even need to know. Although I haven't done the examples yet. What you really want to see probably are the examples, because that's really what your life is going to be like for the life of this section. Okay, here's a little more standard way to prove what the area of this trapezoid is. Again, we have base 1 and base 2 labeled here. Height is defined to be perpendicular. No matter what I do here, it's forcing this thing to be a trapezoid. I can kind of switch this around. I did not make this one. This is one of the pre-made Sketchpad ones. We'll play with this one in class, and I can give you this file. It's kind of fun. Let me make a little more non-symmetrical looking trapezoid. Okay, and one thing they do is, okay, let's take that midpoint again, and let's just take this trapezoid and revolve a copy of it around this midpoint. Now, as you do that, notice what happens here, what we end up with. This thing over here came from this one down here, right? If I just flip that around, this length, this sort of lighter green length here, came from here. So that's base 2. This one was a copy of this once I rotated it. Why go to all that trouble? And of course I could wiggle this and it's dynamic and it stays doing what it was doing. Look at now this entire length from here across the entire top of this new figure. That's base 1 plus base 2. And that's the same across the bottom, which should sort of lead us to believe that, well, wait, hold the phone. What kind of shape do we have here? Well, that's the same as that. This thing, when I rotate it 180 degrees, is sort of pointing the same direction. That is going to have to be parallel to that. What we have here, my friends, is the parallelogram, which is kind of a big deal because we just did parallelogram area in the last day's work. So area of a parallelogram here is really just this times this. Okay, so the area of that is height times, I'm going to run out of room here, base 1 plus base 2. But we don't really have a parallelogram. I mean, the parallelogram is all of this. We don't want all of that. We just want half of it. So, well, I didn't mean to get rid of all that stuff. Ooh, can I bring it back? I can. All right, so we don't want all of it. That's too much. We just really want half of that. Like, we're going to cut half of that off. We just want half. So I want half of what was the parallelogram. I don't want all this. I just want half of h times b1 plus b2. And that, again, is the same exact area of a trapezoid formula. It's half of sort of this double trapezoid, which is a parallelogram, which is then just that part. Isn't that lovely? Okay, fine. So you talked me into doing some examples. Let's say you have a trapezoid here. Whoa, that got kind of wavy there. And I'm just trying to say this entire side here, gosh, did it again, is 4. This entire side down here, let's say, oh, if that's 4, this looks like it might be something like 11. I don't know. So we have a 4, one base. We have a height of 3, 3 apart from, I guess you could say, a base of 11. The formula says I take a half, and I'm not even thinking here, half times 3 times the sum of these bases. Now you could go on all day talking about how you could plug those in there and sort of prove that that's the area formula. Like there's this midline here that's, you know, halfway between 4 and 11, and then that times 3 would be a rectangle that would be this size. I mean, I love that stuff, but you don't have to do it every time. So this would be 15 times 3 divided by 2, which is something like 22 and a half. Okay, fair enough. Now, you're going to be getting some problems that, of course, are going to be a little more fun than that. You might have some crazy trapezoid where they give you this, like they tell you there's 2 right angles here, and they give you this little quasi-hypotenuse side. They tell you that's 10. This looks like it's a little bit longer. and they tell you this is, oh, I don't know if that's 10, this has to be short, let's say that's 8. And they say, okay, now, smarty pants, find the area of that trapezoid. Well, you can always do stuff like this. We could drop this straight down here and say, well, if that's 12, this also has to be 12. Because the problem with this one is I don't have, let me change colors here, I don't have all the stuff I would regularly need to find the area of a trapezoid. I don't have this longer base here. I need to know that. But I know I can make a right triangle here. Like we have this whole parallel thing going on here because it's a trapezoid, so I can sort of copy paste this translation of this segment down here. I know it's going to be the same length. If this is 12, this is 12. And that, of course, if this is 8, I've made a little rectangle in here now. This has to be 8. I do a little Pythagorean magic here. I find out that that side is 6. And voila, I have my other base. And now I can go to town with the formula. Half times the height. Now be careful, the height is not 10. The height is 8. Times the sum of those bases, which is 12 plus 18. Do I want to do all this arithmetic? Yeah, I might as well. Okay, 30, and I can might as well do that there. And so I get 120 as my area of that trapezoid. And there's a bunch of little tricks like that. So don't be afraid if you feel like, oh my gosh, am I really supposed to use Pythagorean theorem? Yeah, I can imagine they can give you some problems with some, instead of giving you this 8, they might give you this the size of this angle, or maybe this isn't a right angle. They give you that. You got to use some SOHCAHTOA to chop off some right triangles and find some things that way. Just remember that in all the, gosh, I can't draw a straight line today. In all of them, you gotta have, I mean, for a trapezoid area from it to work, there's gonna be some parallel sides there, and whatever we're calling the height has to be perpendicular to those two bases. Also, don't be scared by this. Trapezoids sometimes look like this. Like you have one base over here and one base kind of over here, whereas it's like both the slanted sides are kind of like maybe decreasing slope or something. It doesn't have to be that one is sort of centered above the other, or not, or just kind of within the other one. It could be this one's totally slid over from that. Still, there's a height here. There's a height from sort of this level to this level that's perpendicular. Actually, these two trapezoids look like they're the same height. Sort of an accident. But always, it's going to be, area is going to be base 1 plus base 2 divided by 2 times this height. These are the 3 pieces you need to know. Okay, got done in under 15 minutes. Pretty not surprised about that. And I will see you in class.